what the temperature is of blood coming in and the temperature of the blood going out.
So can you use that to tell if somebody's having a fever and an infection and early signs of sepsis, or not really, because the whole body's
It's hard to
constantly
use temperature when
normalized?
you're on ECMO.
At all. There's no
I've
way.
never noticed that. Most of the time,
Sinus
you'll
sepsis.
see like their white count go up. Sometimes that doesn't even happen. It's usually they'll get a little bit of a pressure requirement, and then that's
So what I've seen in the.
What's your trigger?
I mean, if they've been like sort of stable on a dose suppressor, and I see the pressure high, usually send cultures and start looking for signs of infection.
Relative to the Arctic sun, you can kind of achieve the same effect manually. There are these two kind of pipe-looking things that drop off of here. So water-based heater-cooler system. So there's a separate unit. It's not integrated in the pump.
So it's a water-based system.
So you can have a blood work. Now, normally, as you know, anytime you take a patient's blood out of their body and put it back in, you've got to warm it a little bit in order to account for the convective losses on the way out. If you're having to, you can watch the water bath temperature.
Yeah,
And if you've got to keep the water bath temperature way down
So
in order to maintain
kinda like an
normothermia,
Arctic
then
sun.
the patient's fighting you, and you can see the same sort of thing. And of course, the other thing that you may see is if you're trying to keep somebody therapeutically cool at whatever 33 degrees, and you're having to warm them to do that. Generally not a good sign, right? If you
For me,
have
it
to
normally
warm
means they're
somebody to
brain dead.
keep them above room temperature, it's not usually good.
So you'll notice that at this load, the battery basically says you have almost 7 hours, 6 hours, 53 minutes. The moment you start increasing the load, now you have much less. That's why the manufacturer will say 90 minutes, because they
No less than 9
Yeah,
minutes.
it's enough to get through a CAT scan. There's this thing, right?
Do they have an external battery pack?
Yeah,
it's got two
I think
internal
it's
batteries.
I just got notified.
Yeah. It's lunchtime.
Yeah, wanna go lunch? I guess you can ask
How much is
questions
the machine?
kind of all day long anyway.
Uh-huh.
How much is this thing? Curious. It's
It's
$12,000 for the circuit.
No.
Yeah, it's close to 100,000.
100,000.
Yeah.
Because old ECMO was cheaper, right? I heard it's like 2,000-3,000.
Well, it depends
just for
on
a
which-
filter, and it's,
yeah.
you get a centromag off of. But now the circuit's up to 12,000 to put somebody on ECMO versus 2,000-3,000 before,
Well,
right? Or
So this, when you think about this circuit, you have to remember that this is everything. This is
Yeah,
the road flow pump, this is the oxygenator, this is the tubing pack. So when you look at the other systems like road flow and Centromag is much more expensive than, for example, road flow.
so there's a lot of other
So
costs.
variability, yeah, of like, if you're going to build a program, then that's definitely one of the things that you have to.
I heard you're switching all the cardia helps. Is it because you guys like it, it's better, it's more efficient, it's simpler, or you guys are gonna start transporting?
I believe
or
it's safer.
safer?
So, I'm a big fan of inlet pressure monitoring, pre-oxygenator pressure monitoring, post-oxygenator pressure.
And the other ones just didn't give you that as well.
Well, you can do that.
But
You
it's
can
a lot
do
more
that.
hookups.
The problem is, you have to interrupt your circuit
Mm.
to do it. You have to have a transducer of some kind, so you have to have a lured connection. So the moment you start putting connectors in your circuit, you start increasing the
Focus
losses.
circuits.
Yes. So we like to try and minimize that as much as possible.
How much you said the circuit cost?
It totally depends on the facility. I think I wanna say that just the over-the-counter price, if you will, the price that they give when you ask that question, you'd have to ask them, the K boys, but I wanna say it's somewhere in the
Small part on the
16,000 range. The larger the facility, you can probably get it down to 11,000 or 10,000 or something like that maybe, but it's not inexpensive. But for the safety feature, the other safety features this have is that not only does it have it has servo regulation. So if you try to, for example, let's say we put the T venous and we want it to alarm at -60. And we want it to intervene at -80. what that means is that it's going to alarm, it's going to alarm when it gets to -60. It's gonna give you a yellow alarm, it's gonna tell you, hey, look over here at me. But then once it gets to -80, once it gets to -80, it's not going to let you go above that. It's gonna servo regulate, so even if I turn this dial
Not gonna
all the
change.
way up to 5,000, you'll notice that my flow did not change.
I'm sorry.
Because the machine itself is saying, you said 80 is, you don't want me to go over 80, so I'm not going over 80.
What does the word servo mean? I've heard it talked
So it
about, but I
means
don't
that the
know.
RPMs of your centrifugal pump are regulated by another external factor. So in this case, the external factor is the venous pressure. So this is in a stable system, but your patient's not a stable system, so there's constant fluctuations. So it will sense this negative pressure, and your RPMs will go up and down to maintain, to make sure that you do not go over -80. Every time you try and go up over -80, or if there's an increase in resistance, for example, Pat, do me a favor, put a small clamp on the venous side. Watch what happens to your RPMs. Oh, you broke it. He took a big clamp. Alright, hold on. Here. Oh, that's the air. Never mind. There's air in the system. Alright, there's air in the system jacking this up. So it's hard for me to explain that to you. So I'm gonna put this up. But what happens is, as there's an increase in resistance on the venous limb, that pressure's going to become more negative, right, if you left the flow the same. But because that resistance increases, that negative pressure is -80, so your RPMs is gonna go, ooh, hey, slow down a little bit. So it'll decrease until it reaches equilibrium, and then it'll go up and down to try and keep that negative pressure same.
Can I put a servo on my teenagers at home?
Well, if you
Like
get
that.
that mechanism,
Auto
let me know,
regulate
'cause I'm gonna
them.
order
That-
3.
that'd be
And the transport capability does support the program in the sense that, you know, at outlying facilities, you may have patients who have reached the point where
And
they're
it's-
essentially too unstable to transport the way they are, they need ECMO, but the facility doesn't have that capability, you can get a team out there to cannulate them,
then
get them on
log
ECMO,
people
and
and
then
bring them.
transport them.
And you can get them on.
Yeah.
Yeah.
And in truth,
Are we doing this in the system, because we haven't called you guys?
Uh,
Fair Oaks.
We have not started to cannulate outside the
Outside?
facility yet.
Okay.
We do get, you know, there are a couple of facilities, Walter Reed, that,
ACU mainly.
where the
Where the team
the
comes.
surgery team
VCU's,
will
yeah,
cannulate
VCU's
somebody,
team came to us to cannulate, but.
so put
But
them
they-
on whatever they have, but then they don't have the staff to take care of an ECMO patient, pack them up and
Problem
send
with
it to
VCU
us.
is for VVA, they don't do lung transplants. So they have a
Yeah.
limitation of care. If they pick up somebody for, that's when I normally use it, is for pulmonary failure. They, it's like, well, but he's probably fibrotic phase, we won't take him. Versus a transplant center where we do lungs here, so it'd be great if we can, well, it is great.
Yeah.
But
One of
we
the-
do VV here.
one of the